topic today is sound waves. So we will try to understand how sound is produced, how sound is propagated, means how it travels from one place to another place, and at last we will discuss the nature of sound waves. That is to prove that the nature of sound waves is longitudinal. So here in sound waves, first we are going to discuss production of sound, means how sound is produced. Like all other mechanical waves, sound is also a kind of mechanical waves, and in mechanical waves sound is always produced by some vibrating body. So we can say sound is produced by vibrating body. How? Suppose we have a tuning fork. This is a tuning fork, and here we have a rubber pad. We hit this tuning fork with this rubber pad. Its prongs will start vibrations, and thus we will hear sound. Its prongs will start vibrations, and thus we will hear sound. How we will come to know that whether this tuning fork is vibrating or not? We will hit it with a rubber pad and we will bring it near to one of our cheeks. We can feel its vibrations. Or in other words, if we have a glass filled with water, okay, you put a vibrating tuning fork into the water, and what will happen? We will see vibrations are produced in the water. This proves that there were vibrations in the tuning, and thus sound is produced. Or in another case, you pluck a wire of a guitar. What happens? That string starts vibrations and we hear sound. Okay, we have to vibrate any body to produce sound. Now the second thing is how sound propagates, means how does the sound travels from one place to another place. We will write propagation of sound. So for a sound to travel from one place to another place, we need a material medium. This material medium can be some gas, some solid, or some liquid. For example, when I speak, then the voice reaches up to your ear because of the air between us. If there was no air, then we were not going to hear any kind of sound. We can prove it with the help of an experiment. What is that experiment? Take an electric bell in which you must be able to see a hammer hitting the bell. You will fix this electric bell in a jar. You will give it a power supply through a switch, and this bell jar will be placed on a rubber pad having a hole, and this hole will be attached with a vacuum pump. Now what will happen? When the switch is on, we will see hammer hitting the bell, and we will hear the sound of the bell. Next, what we are going to do is create a vacuum within the bell jar. This is create vacuum within this bell jar with the help of this vacuum pump. That is, you make it empty. There must be nothing within this bell jar, even no air. Now what happens? When the switch is on, we see hammer hitting the bell, but we will hear no sound. Why? Because there is no material medium around this bell, and so the sound cannot travel from this bell up to this bell jar and then up to our ears. So this experiment proves that for the propagation of sound waves or for traveling of the sound waves, we need a material medium, and here on earth we have air as a material medium. Now the number 3 is nature of sound waves. What is nature of sound waves? So the nature of sound wave is longitudinal. How we are going to prove it that the nature is longitudinal? Again, we will take a tuning fork in this shape. It has two prongs. When we hit it with a rubber pad, here a bigger rubber, you hit this tuning fork with this rubber pad, its prongs starts to vibrate. How these will vibrate? This is the mean position of the prong denoted by O. This will vibrate between a position A and B. When the prong will move towards B, what will happen? It will compress the layers of air. Here, when the prong will move from A to B, it will compress the adjacent layers of air, and this compression will start moving towards your ear. Now what happens when this prong moves from B to A? Then it will rarefy these layers of air, these adjacent layers of air. So what will happen? When this prong will move towards A, it will rarefy the layers of air. It will pull back the adjacent layers of air. Thus, rarefaction is produced. And when this prong vibrates very quickly between A and B, then what happens? A compression moves in the forward direction, a rarefaction follow this compression, and after this rarefaction another compression comes. Thus we get waves in this form. A compression, then rarefaction, again compression, then rarefaction, and again compression. In it we see when compression comes, the particle of the medium or the particle of air moves in the forward direction. When rarefaction comes, this particle moves towards left in the backward direction. Again, when the compression comes, it moves in the forward direction, and when the rarefaction comes, it moves in the backward direction. Thus, these particles move to and fro in the forward and in the backward direction, and their motion of vibration is parallel to the propagation of the wave. Wave is advancing towards right, and the particles are vibrating parallel to the propagation of the wave. Such kind of waves are called longitudinal waves. So this illustration proves that sound waves are longitudinal in nature. The nature of the sound waves is longitudinal. That's enough for today.